Hi guys, this morning we're going to talk a little bit more about multiplying decimals. Now, you started working on this yesterday, and we're going to go a little bit more in depth today to try and notice any patterns that we use when we're multiplying decimals. So look at the problems below. What do you notice in all three of the problems regarding the number of digits behind the decimal in the factors and the number of digits behind the decimal in the product? Take a second to look, and then we'll talk about it. All right, so let's take a look. When I'm looking at the first problem, I have one number after the decimal. In my answer, I have one number after the decimal. In this problem, I have two numbers past the decimal. Here, I have two numbers past the decimal. Here, I have two numbers after a decimal, and here I have two numbers after a decimal. So this makes sense because if we think about it visually, we have our three groups of 500ths. So when we have whole groups of a decimal value, the product will include the same unit. So in this example, we have three groups of 500ths. I didn't leave myself enough room. And this would result in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 hundredths. So our product includes the same number of units that we see in our original problem. Same thing. When we multiply tenths by tenths, such as this example, which is 9/10 times 7/10, we are cutting each tenth into 10 parts. So the unit of our product will be hundredths. For 9/10 times 7/10, we cut the tenths into 10 parts, which created the hundredths. Remember? Therefore, the product is hundredths. So thinking about how we are using this now, let's talk about a general code or a general rule. So if we're looking at this, what place value would the product of 2 and 4/10 times 1 and 7/10? I have one number after the decimal, two numbers after the decimal. Remembering our place value chart, we have our ones, our tenths, our hundredths, and our thousandths. Here's our decimal, we have 1, 2, 1, 2. So it would be in the hundredths. What place value is the product of 5/10 and 9b? We only have our one digit after the decimal. So this is going to be in our tenths. All right, here's another one. What is the product? What place value would the product have of 500ths times 1 and 3/10? We have two digits here, one digit here. So we would have, this would be in the thousandths. Okay? So let's see if we can apply this to our regular problems. 1 and 3/10 times 2 and 4/10. So the first thing we would do is actually rewrite the problem vertically, up and down. So let's look at this. We can multiply all of this out. We can do 3 times 4 is 12. I'm going to carry my 10. 3 times 2 is 6, plus the 1 is 7. I'm putting my placeholder egg here. And then 1 times 4 is 4. 1 times 2 is 2. Add it all together. I get 2, 11, 3. But I can't leave that as my answer because I have decimals in the original problem. So this is telling me I have 2 numbers beyond the decimal. So I'm going to put my decimal right there. Okay, does that make sense? Let's try another one. So this time we have 2 3500ths times 4 8/10. So the first thing we think about when multiplying decimals is, what is the approximate value of each of these? What is it approximately going to be? So our 2 3500ths is closest to 2, because remember, this number here is going to tell us if this number here is going to go up or stay the same. This number is roughly 5 because this number here is greater than 5, so this means it's going to go up. So roughly, our answer should be around 10. So let's figure it out. Now, this is an approximation. Remember, it's an estimate. So we're going to take our numbers and rewrite it. We drop our decimals, we don't worry about them, and we multiply like we normally would. 8 times 5 is 40. 8 times 3 is what? 24 plus 4 is 28. 8 times 2 is 16 plus 2 is 18. We put our placeholder egg. 4 times 5 is 20. 4 times 3 is 12 plus 2 is 14. 4 times 2 is 8 plus the other one is 9. And then we add it all together to get 11,280. But wait a second, we said our answer is going to be close to 10 or around 10. So there has to be what? We are missing our decimal. Now we have 3 digits in this first number and 1 digit in the second. So I'm going to count 1, 2, 3. So our answer is 11,280 thousandths. Now, I know that this 0 here really doesn't matter because it's just a place value. But this means that the product is no longer the thousandths as we originally thought it should be. Although it seems that this answer does not have the 3 digits behind the decimal, it actually did when we included the 0 in the thousandths place. So as we said before, we can write it as this, or if that's confusing, you can write it as this. Okay? Because this way we know that we have our 3 digits past our decimal values like it's supposed to. So, keeping in mind what I just said about final digits, let's talk about this. Which of the choices below represents the product of 14 3200ths times 4 5/10? Let's look at these answer choices. I notice that all the choices have the same digits, 6, 4, 4, 4. So in order to answer this question, we need to think about which option is the most reasonable and which option has the correct placement of their decimal point. So let's first consider which of these answers is the most reasonable. To determine this, let's approximate a whole number for each factor. So we know that 14 3/10 is closest to 14, and 4 5/10 is closest to 5. And if I multiply 14 times 5, I'm going to get an answer of 70. Next, let's think about the correct placement of the decimal. Looking at the factors, what place value should the product be in? We have our 2 numbers here, 1 number here, so that means it has to have a thousandth. We also know this because when we multiply our hundredths by our tenths, our product is always in the thousandths. And we can notice that there are 3 digits after the decimal points in the factors, so there will be 3 digits after the decimal point in the product. Okay, so we know the answer should be around 70 and should have digits in the thousands. So which choice is about 70? Well, we have answer C. But wait a second. The problem is that that answer doesn't have a product in a number in the place value thousands. So is that the right answer? Think about what we just did in the last problem. We saw that a product can end in a 0 and therefore be written in an equivalent form. So in this case, 64440 can also be written like this. It is important that we consider the place value of the product and the reasonableness of our answer, meaning what was closest to our original estimate. Because if we had only considered the place value of the product, we would have chosen B because it's the only one that has a number in the thousandth column. But based on our guesstimate, our approximation of the product, we knew that B could not be the answer. And if you want, you can always double check your answer by multiplying it out. 5 times 2 is 10. 5 times 3 is 15 plus 1 is 16. 5 times 4 is 20 plus 1 is 21. 5 times 1 is 5 plus 2 is 7. Placeholder egg. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16 plus 1 is 17. 4 times 1 is 4 plus 1 is 5. And add them all together. There's our numbers. Put our decimal place point 3 numbers after from the end. And there we go. So this way we can verify that our original answer of C is going to be our correct answer. I hope this helps you guys figure out how to do your work for today. If you have any questions or comments, you know you can always comment down below and I will get back to you as soon as I can. Have a great day, guys.